Today is a beautiful day for science. Currently, we're looking at the sun's activity, less of a regional situation, but more of the sun as a whole. We're going to take a quick look at space weather and solar activity that occurs based upon uh, just how the sun operates in general. It's constantly emitting particles, constantly emitting solar wind particles, which are just faster sun particles, and density particles, which is just the cooler, denser plasma, and it creates these bands. Now, think of it more like a water sprinkler. The water is shooting straight out, but if you look from the top down, you see this water shooting straight out, but you see almost like a spiral effect. So it looks like it's spiraling, but it's really not. It's just that as that water moves further out, the area that was dispersing that water has moved a little more forward. So it's creating this nice little spiral effect, though the water is just moving straight out, just like these solar particles. These solar particles are moving just straight out from the sun. But it creates a spiral look or effect, illusion, as it were, that makes it look like it's actually, a spiral. Anyhow, so this solar wind particles we're looking at currently is more focused on, we just had a G2, which is a little more significant than I had expected from the density band. The density band's being pushed and condensed by the solar wind band. Let me go ahead and make this a little bit smaller since I'm not focusing on the sun itself at the moment. And turn off my footy me bananas. I've named the image that puts that black background up, footing me bananas. I don't know why, just decided to do that, and so there it is. All right, so as we look at it, we can see, let me pull up, all right, so here's the density band, and as this density band impacts, that's what led to our G2 activity, and it's being pushed in, and even though everything there is now a non-collisional plasma, it's causing a lot of space between all those particles, as we're not getting hit by a bombardment that's that much impacted. It doesn't mean that there's not a difference between a denser cloud and a less dense cloud. When these solar particles are expanded to a non-collisional situation, they can still have a sort of level of play to where they're denser and they're not, much like any gas, even though this is all charged gas, which is plasma. Anyhow, so looking at this, we see that we just had that density event that caused those G2 level storms. And that's why we didn't see the wind band or the measurement of wind go up on ACE, which is the wind satellite, or Discover, nor on our local station satellites as well. But what was pushing that is what makes it more interesting, because we have, and we're starting to see the impacts of the wind densities, the wind particles rather, solar wind particles, that are actually putting to play that density band. And this is indeed why I'm expecting another G2 level event. Even though the G2 we had from the density band was a little bit higher than I expected, I still expect approximately the same thing, another G2. I'm not really expecting anything more significant than that. So we do have a good chance of auroras, but it's going to be coming in 2 points, 2 volleys, as it were. We have the weaker burst of solar wind, and this is because this solar wind caught up with that density band, and it started pushing all that density band together, because they work like bumper cars. They can't go through each other. They don't cannibalize. These solar wind particles don't cannibalize each other. That was a weird article NASA put out a while back. But they work more like bumper cars. Now, more like a jello or a gelatin bumper car, granted, so you can cause some deformity and fluctuation, but it still remains in its layer, in its position. And so we have these faster wind particles have been slowed down, but they caused an increase of speed to those density particles and caused them to be bumpered closer together. And thus these wind particles are the same. But as this passes, and time passes, we're going to see that the area that these wind particles are coming from, and sure enough, it's going to be the coronal hole, which is basically like clear skies for the sun, like we have the upper atmosphere we have for Earth, If when there's no clouds, that it's clear sky, that's what it is for the sun. And here, indeed, we're going to have that corona hole in optimal position to where it's putting out that solar wind particle jet stream and going to be impacting us. And that, I believe, is when we're going to start seeing those G2 level storms. Nothing significant. We will probably see some more adjustments to the satellite technology to react to all of the satellite drag that may be incurred from the drag of additional particles in the upper atmosphere. But on the ground, mostly for us, we're going to be seeing an additional level of aurora. So definitely a good chance to get some imagery and look at the beautiful skies. And yeah, so I just wanted to point that out because that is what's some of the fun stuff that's up ahead. And yeah, that's it. Even though none of this is from an interplanetary coronal mass ejection, ICME, this is something that can be still caused just by the natural wind bands and density bands from the sun. So our space weather, as it were, without the actual events, eruptions from the sun. Very beautiful and very exciting, and also a little more telling that there's far more to space weather, as it were, than just looking for solar flares and coronal mass ejections. All right, well, that's it. Cheers and science on.